Hi, this is Chris Armstrong from SIGLENT Technologies. Here today to talk about our measurement capability for real-time eye diagrams. This option is supported in our high-speed oscilloscopes at or above a gigahertz, including the SDS6000A and 6000L series. The real-time eye mode itself includes 6 standard measurements, including interval error, eye height and width, the 1 and 0 levels, as well as an eye crossing. We've also built in an advanced mask test setup for pass-fail measurements using either a custom or a built-in mask. The system comes with advanced clock recovery, as well as an easy setup view. Let's go ahead and take a look at the eye diagram testing in action. Here we have a PRBS signal. We can go into eye diagram mode, and we immediately see it pop up here. Or you can also hit the quick view. Now you can see the timing. We can look at the measurements at the bottom of the screen. We can also look at different ways to configure this. Change the clock recovery and change the way it appears in the screen. We also have a mask test capability. Let's go ahead and turn that on. Now we see that mask I built came up in the middle of the screen. Now let's take a look at this signal a little bit and make some changes to that. We can add some noise to that signal. We can increase and decrease the amount of noise using our waveform generator. And you can see how it affects the signal in terms of the overall eye diagram and in relation to the mask setting. You see most of that noise appears across the top and bottom bars of this PRBS signal. We can also see that in its default state, that mask test will stop on a failure. We can go ahead and go back into the menu and change that so it only counts as failures or beeps at you instead of actually stopping. And then we can hit the run stop button and get that rolling again. Now instead of the noise, let's look at the bandwidth. So we can change the bandwidth filter on this signal as well. And we can see as we decrease the bandwidth, we get closer and closer to that eye until we're failing consistently. Right? So the bandwidth really sets that rise fall time. So we can go back to our standard signal there as well. And here's where you can really just capture both the signal quality, make sure you're getting good digital communication through your signal path, and in the end, do a complete analysis of your communication pathways.